Welcome to Session 2 of the VPLEX Fundamentals. In this session, we're going to focus on the architecture and components of the VPLEX system. This session focuses on the architecture and components of the VPLEX solution. The diagram here displays a fully populated VPLEX 5.0 cabinet. Notice the VPLEX numbering starts from the bottom up. Every engine contains a standard power supply. The difference between a quad and a dual engine is that the dual engine is a removal of two engines and a single SPS. A single engine implementation contains only a management server, engine, and a single SPS only. VPLEX engines can be deployed as a single, dual, or quad cluster configuration depending on the number of front-end and back-end connections required. VPLEX's advanced data caching algorithms are able to detect sequential reads to disk, and as a result, VPLEX engines are able to fetch data from disk to cache in order to improve host read performance. A VPLEX engine is a chassis containing two directors, redundant power supplies, fans, I/O modules, and management modules. In the VS2 engine, we have 10 I/O modules, 5 allocated to each director. Each director has one 4-port 8 gigabit per second fiber channel I/O module used for front end, and one 4-port 8 gigabit fiber channel I/O module used for back end. Each of these modules has a 40 gigabit per second effective bandwidth to the CPU of their corresponding director. A third I/O module called the WAN-COM module is used for inter-cluster communications. There are two variants of this module offered. One is fiber channel, the other is 10 gigabit Ethernet. The fourth module provides two ports of 8 gigabit per second fiber channel connectivity for intra-cluster communication. The fifth module space is reserved for future use. For VPLEX Metro and Geo, an optional component called the VPLEX Witness can be deployed at a third location to improve data availability in the event of a cluster failure or inter-cluster communication loss. The Witness is implemented as a virtual machine and requires VMware ESX server for its operations. The VPLEX Witness observes the state of the clusters and then can distinguish between an outage of the cluster link or a cluster failure and use this information to guide the clusters to either resume or suspend I/O. The VPLEX product family currently has VPLEX Local, Metro, and Geo. VPLEX Local provides a single cluster or cabinet that manages a local storage network. A VPLEX Metro enables active block-level access between two sites. VPLEX Geo extends the distance of the VPLEX Metro offering to an asynchronous distance of up to 50 milliseconds round-trip time via IP configuration. VPLEX Architecture allows data to be accessed and shared between locations over distance via distributed federation of storage resources. VPLEX with Synchronicity is open and heterogeneous, supporting both EMC storage and third-party storage vendors such as HDS, HP, and IBM. VPLEX conforms to the standard worldwide name guiding conventions that can be used for zoning. This is a high-level architectural view of the management connections between the management server and the directors. The directors are daisy-chained together via two redundant Ethernet connections, an A and a B channel. The management server connects via its own separate Ethernet connections to the directors in the cluster. The management server is the only VPLEX component that is configured with a public IP address for remote connectivity using SSH or HTTPS. Cache coherence creates a consistent global view of a volume. The distributed cache coherence is maintained using a directory. There's one directory per volume, and this directory is split into chunks. These chunks only exist if they're populated. There's one directory entry per global cache page with responsibility for tracking page owners, remembering the last writer, and locking and queuing. Virtual volumes presented out of a VPLEX can tolerate port failures by connecting the host to multiple directors and utilizing multipathing software to control the paths. Virtual volumes are presented out of multiple VPLEX front ends on different directors to enhance the high availability feature. All supported VPLEX configurations ship in a standard single rack. Engines are numbered 1 through 4 from the bottom to top. Any spare space in the shipped rack is to be preserved for potential engine upgrades in the future. This table provides a quick comparison of the 3 different VPLEX single cluster configurations available. This session provided an overview of the VPLEX architecture. We looked at a review of the VPLEX architecture, a list of key architectural terms, an overview of the VPLEX topology options, and an introduction to the components in VPLEX. This concludes Sessions 2 lecture material and introduction. From here, please go ahead and read and view the videos and PDF files that have been supplied as part of this session. Then go to our discussion forum and answer this session's questions. Remember to interact with the other members of the session by responding to their answers and to give them suggestions or comments about how they answered. Let's get a good discussion going this session. Thanks.